Okay, so if you wanted to take the limit as x goes to 1 of 3x squared plus 4x, it's actually really easy to do. And what I want you to know is that you can break this up into two limits. So if you notice, if you do the limit as x goes to 1 of 3x squared plus 4x, you get 7. And if you break it up into two pieces, you end up with 3 plus 4, which ends up being 7, right? So the idea is that if you have the addition of two functions, you can break it up into what is x goes to a of f of x plus the limit is x goes to a of g of x. And we're not going to write it out for every one because that would just take a lot of time, and I think intuitively you guys can understand what's going on. Okay, so again, you could pull it apart into two pieces, and you're like, why would you do that? I'll show you here in a second. Let's say subtraction. We could, just write a subtraction. If we have a constant, we could put the constant out front. So like a constant times the limit as x goes to a of the function. So you can pull a constant out of the function, still evaluate the limit. You can multiply them together. You can divide them. You can raise it to a power. Yeah, it's, I think it's just probably going to be a waste of time because we know what it is. Like, we would just be writing this over and over again. Limit as x goes to a of f of x, and then minus limit as x goes to a of g of x. And I just, we would be doing that same thing all the way through. So just, well, so 6, it's just that we could take the limit as x goes to a of the function, and then we could just raise it to that power in the end. The interesting part about a constant, though, if you look at number 7, the limit is x goes to a of c. So somebody give me a constant. Okay, so I have f of x is 7. What does that graph look like? Jake said we're going to do 7. What does that graph look like? Horizontal line through 7, okay? So if I were to look at that horizontal line that passes through 7, what is the limit as x goes to 1 of 7? As I go to 1, what is the output move towards? 7. How about as I move to -3? How about 20? So the limit of a constant is always the constant. Very good. So in this situation, the limit as x goes to a of a constant is that constant. And for these, we can simply just substitute a. So limit as x goes to a of x is going to be a. You just plug it in, and that's what you get. Here you're going to get a to the nth. Here you're going to get the nth root of a. Forget about 11, but for 12 it says direct substitution for polynomial or rational function. The limit is x goes to a of f of x is f of a. Most of the time what we can do in order to evaluate a limit is just simply plug in the value and we're going to come up with a result. No big deal. Okay. So we're going to look at 3 different ways of evaluating limits today. We're going to look at tables, we're going to look at graphs, and then we're going to look at the substitution piece to do some algebra. Let's look at the basic one first. It says, given that limit as x goes a of the function is 6, and as x goes a of g of x is -2, what is the limit as x goes a of f of x plus g of x? Anybody want to take a shot at what we might do there? Yeah, 6 minus 2. You don't have to write this out every time, but I just want to be clear that we're using one of the laws of the limits. We're separating it into two pieces. And you can see the limit as x goes to a of the function is 6, and then of g of x is -2, so I get 4 in that scenario. So how would I evaluate b? 6 divided by 0. Now, that's a little bit more confusing. I'll show you why. A lot of times we see 6 divided by 0. A lot of people would write undefined. That's not always true with limits, okay? Because would you agree that in this situation that the function is undefined right there? Yet what's the limit? Infinity. So sometimes you're going to get positive infinity, sometimes you get negative infinity. Would you agree that in this situation as well, the limit does not, or I'm sorry, that it's undefined right here? Is there a limit? So we really don't know. You know, we get 6 over 0. It could be infinity, it could be negative infinity, it could be does not exist. So I guess we'll write undefined, meaning we would have to find another way to determine it, okay? What do you think we do for C? Yep, negative 3 times negative 2 plus 5, so 6 plus 5. That limit is 11. And how about D? Very good, Spencer. We get 6. So that's just a basic example involving kind of table values. Let's look at a graphical example. This is f of x. This is g of x. It says the limit as x goes to 1 of f of x times g of x. Well, first of all, what's the limit as x goes to 1 of f of x? It is 3. How about the limit as x goes to 1 of g of x? Negative 1. How about as x goes to 0 for f of x? Approximate. Sure, 2.6. Minus 3 times. How about g of x? Negative 2. So we get 2 times 2.6 is 5.2. Plus 6 is 11.2. Letter C, g of x divided by f of x. What's the limit as x goes to 2 of g of x? Well, that's from the left side, but I have to check the right side. It's a two-sided limit, right? Yeah, when you see this thing, okay, that's kind of the barcode function. So it doesn't zero on one value, and plus these wouldn't be the same anyway if it did. So you have does not exist divided by, as f of x approaches 2, I maybe have say 2. If one part of it does not exist, then the whole thing does not exist. What about D? What do you think I do with that 2x squared? What do you think I put in for x? 5. And what is the limit as x goes to 5 of f of x? Yeah, it's 4. Very good. If I multiply that out, I think I get 200. Okay. So now you've seen graphs, you've seen tables. Now let's just do a little bit of basic algebra. Evaluate the following limits. As soon as you see a limit, the first thing you like to do, especially if you have a polynomial, is you like to just plug in the value and see what happens. If we plug in 1, do we get an output? 1 minus 3 plus 1. Nice and easy, right? Can we plug in 0 here and get a value? What's the cube root of negative 27? Negative 3. What if you plug in 0 for, what if you plug in 3 for letter C? So hopefully there's something that we can do to adjust this, and we'll look at that when you get back. Go get some brain food. You notice that in this situation, you get 0 divided by 0. Now, when you get that 0 divided by 0, you're going to end up with this kind of situation, okay? Where you have a limit that exists, it's just that there's a gap in the graph. So we want to figure out what that gap is. Namely, if we are approaching 3, okay, from the left and the right, what is the y value approach is what we want to find out. And it's not that bad to figure this out. We just take the limit as x goes to 3 of x plus 3 times x minus 3, and we divide it by x minus 3. And what that tells us is that this graph really wants to look like x plus 3, but it's got a gap in it. That's the only difference. So we take this value of 3 and we plug it into what remains, 6. So it turns out that this has a height of 6 right there, that's where the gap is, 3, 6. Okay? That's what happens. And if you don't believe me, just graph it on your calculator and you're going to find that. You'll find that gap right there. Okay? All right, the next one, what should I do? If I plug in 0, I get 0 over 0. So we have the limit as x goes to 0 of x times x minus 5 divided by x times 1 minus 4x. So you can see the x's cancel. And when they cancel, can I plug the 0 in then? I get negative 5 over 1. Flip it over. How about e? What if you plug in 0 there? Still get 0 over 0. That's a problem. What do you want to do? Whoa. Go home? Okay, we're going to go home. It's a plan. What if we needed to do calculus? What would we do? G to bowl stupid for lunch or what? Well, I wouldn't take that if I were you. Okay, let's multiply this out. I have the limit as h goes to 0 of h squared minus 4h plus 4 minus 4 all over h. Just multiply it out. You can see that the 4's cancel. Thank you. Let's take out an h. We get h minus 4. Can I plug in 0 now? You do get negative 4. Good job. Letter F, if I plug in 0 there, what happens? So what should I do? Multiply it out. Remember how to do that more quickly? Yep, thank you, Aaliyah. Triangle thing. Pascal's triangle. Binomial theorem. This could be the limit as h goes to 0 of h cubed plus 3h squared plus 3h plus 1, then minus 1. All over h. Cancel off the 1's. Emma, what would you like to do? Take out the h. H squared plus 3h plus 3. 3 is the answer. Nice job. Four left. It's been way too easy so far. What now? The conjugate. Okay, so Levi and Andrew have some great ideas. Now, there's two ways to do this problem. I'll multiply by the conjugate, and then I'll show you another way to do it that I think comes in handy quite often. So I'm going to multiply by 1 plus the root of x. So when you don't know what to do, do Spanish. Multiply by the conjugate. And in the denominator, we get 1 minus x. Agreed? It's the conjugate, so the middles are going to go away. In the numerator, we have 1 minus x times 1 plus the root of x. And you can see that those cancel. I'm going to do it a different way. I'm just going to start by factoring it. Limit as x goes to 1 of, I'm going to factor this top piece as the difference of two squares. What times what is 1? What times what is x? The root of x. If you don't believe me that 1 minus x factors to that, try it. Work it out. It does. So you can see in this situation, whoop. Yeah. It's 1 minus the root of x in the denominator. Either way, you end up with 1 plus the root of x, and when you plug in the 1, you get 2. For h, we're going to multiply by the conjugate as well. But this time, instead of multiplying, the conjugate of the denominator, we focus on the numerator. What is the conjugate of the numerator? Very good. The only thing that changes is the ending. Just like when we conjugate in Spanish, we change the ending. The only thing that changes is the end. And I get the limit as h goes to 0 of, what do I now have in the numerator? And in the denominator, we have all that stuff. We're going to leave it with h, and root of h plus 9 plus 3. H. So the limit as h goes to 0 of what remains in the numerator? 1, because you had h divided by h. Then we have the root of h plus 9 and plus 3. Can I now plug in 0? What do you get? 1/6. Two examples left. What to do with I? What happens if you plug in 0? Why doesn't it work, Ty? You have 0 in the denominator right away. That's an issue. So maybe, so in the denominator we're fine, but in the numerator we got a 1 over 0. So let's simplify this complex fraction, see if something cancels. Multiply top and bottom by x. Multiply top and bottom by 16. And I get the limit as x goes to 0 of 16 minus x squared over what? 16x over okay, now what? By now what? You can factor the 16 minus x squared into what? Not x plus 4 and x minus 4. Very good. 4 minus x and 4 plus x. And Emu is saying that we are going to then factor out a negative. And she's correct. Okay, so she sees this and she says, I would like to cancel those out. But before I do, I must factor out a negative. So you can see we have limit as x goes to 0 then of negative 4 plus x divided by 16x. So can we plug in the 0 now? We still end up with 0 in the denominator, don't we? In this situation, there's no way to really get rid of it. You can see that we talked about it. When you get this undefined piece, it appears, we might have, as Carter said, does not exist, or we might have infinity, or we might have negative infinity. There's no way of determining it algebraically. We must look at the graph or the table. So I'm going to look at the graph. I'm just going to type it in. So the directions for this type of an assignment would say, let's look at confirm it algebraically if possible. If not, look at a table or a graph. So parentheses 4 plus x, and we're going to divide it by, remember your parentheses, 16x, and zoom 6, zoom standard. You can see what I get. Not much to see there. If I zoom in on that, I'm going to zoom as a decimal. That will bring me much closer in this scenario. Is this a one-sided limit or a two-sided limit? What's the limit as I approach x from the left? Right? So therefore, does not exist. I want to be clear that you don't know, just because it comes up undefined does not mean that it's a does not exist problem every time. It could be infinity, it could be negative infinity. You got to be careful with that, okay? Might have to investigate. Because it's from the left it's positive infinity, from the right it's negative infinity. And so those are not the same. It must be the same from the left as the right. Okay. Question. Calculator, yes. Yep. Exactly. If it said, if the problem was written like this, long as x goes to 0 from the negative or the left, then the answer would be infinity. Very good. Okay. All right, last example. Absolute value, two results, a positive and a negative, correct? If you want to get rid of an absolute value sign, you must create two problems. One that's positive and one that's negative. X plus 5 divided by x plus 5 is 1. Negative x minus 5 over x plus 5 is negative 1. So I multiply through by negative 1. Okay, so we have a positive and a negative solution for our absolute values. And so we know that this function is always going to be either negative 1 or positive 1. And if we look at the graph, if we type it in, the absolute value, I could go to catalog to grab ABS, analog braking system, x plus 5. If I divide it by parentheses x plus 5, and I look at my window, I'm going to go from negative 7 to negative 3. And I'm going to go from negative 2 to positive 2. Look at what this graph looks like. Has a value of negative 1, and then right here, okay, at this value of negative 5, you can see it jumps up. Okay? So is this a one-sided limit or a two-sided limit? The limit from the left, the limit from the right. So does the limit exist? No. Please don't make the mistake of saying, oh, so if it's an absolute value, it does not exist. That's not true. Kelvin just made the excellent point before that in this situation, if you create a left-sided limit or a right-sided limit, then obviously the answer exists. So you have to make sure that you see the problem all the way through and look at it. Don't make assumptions. Here's our schedule here, okay? Tomorrow, you have a very short lesson with a short assignment, and I'll also give you the study guide. On Wednesday and Thursday, you have both those days to work on the study guide as well as your assignments. On Tuesday, when you get back from your little break, because you have Friday, Saturday, Sunday, and Monday, we will then test on that Tuesday. So please make sure you're focusing on your math this week so that you can start asking questions on Thursday on your study guide. Okay? This is generally a very, very good test for people. I imagine you'll do quite well on it as long as you're keeping up with your stuff. Okay?